Dear all, welcome to my channel. If you found my videos helpful, then like and subscribe to my channel and comment for relevant questions. In continuation of the last lecture, today we are going to discuss the fifth rule of differentiation, which is product rule. If f of x and g of x are differentiable at x, then so is their product. And the product rule is defined over here. Derivative of the first function, and we keep the second function as it is, plus first function as it is and derivative of the second function. For example, if we wish to find the derivative of the function y, which is the product of two functions x square plus 1 and x cube plus 3, then in this step we are applying the derivative on both sides. In this step, derivative is applied on x squared plus 1 and x cube plus 3 by using product rule. And according to product rule, we are keeping the first function x squared plus 1 as it is, and derivative is applied on the second function. Plus, we are keeping the second function x cube plus 3 as it is, and derivative is applied on the first function. In this step, derivative is applied on x cube and 3 separately by using sum difference rule. Similarly, derivative is applied on x square and 1 separately by using sum difference rule. In this step, derivative of x cube is calculated by using power rule, and according to power rule, exponent is written over here and 1 is subtracted from the power of x. Similarly, derivative of x square is calculated by using power rule, and according to power rule, power is written over here and 1 is subtracted from the power of x. Since the derivative of any constant is 0, therefore the derivative of 3 and derivative of 1 both are 0. After multiplying 3x square with x square plus 1, 2x with x cube plus 3, and adding the resultant terms, we will get the required answer. Here is the sixth rule of differentiation, which is the quotient rule. If f of x and g of x are differentiable at x, and if g of x is not equal to 0, then the quotient rule is defined over here. Derivative of f of x over g of x is equal to square of g of x. Here we are keeping g of x as it is and taking the derivative of f of x, minus f of x is as it is and taking the derivative of g of x. For example, if we wish to find the derivative of y, which is equal to t square minus 1 over t square plus 1. In this case, f of t is represented by t square minus 1 and g of t is represented by t square plus 1. In this step, derivative of f of t is equal to d over dt t square minus 1. In this step, derivative of t square and 1 is applied by using sum difference rule. Derivative of t square is calculated by using power rule, and according to power rule, exponent is written over here and 1 is subtracted from the power of t. In this way, derivative of t square would become 2t, and derivative of 1 is equal to 0 because the derivative of any constant is 0. In this step, we are taking the derivative of g of t, which is equal to d over dt t square plus 1. In this step, derivative is applied on t square and 1 separately by using sum difference rule, and derivative of t square is equal to 2t, which is explained earlier. In this step, dy by dt is equal to this by using the formula of quotient rule, and all the calculated terms have been put over here, and after calculations we are getting the required answer. Here is the seventh rule of differentiation, which is chain rule. Suppose that we have two functions f of x and g of x, and they are both differentiable. If we define f of x is equal to f of g of x, then derivative of f of x is equal to derivative of the function which is outside, and the inside function is as it is, multiplied by derivative of the inside function. And it can be explained as, if y is a function of u and u is a function of x, then dy by dx is equal to dy by du into du by dx. For example, Find the derivative of f of x is equal to sine 3x square plus x. By using expression steric, which is this, we are calculating the derivative of sine 3x square plus x. Here, the derivative, since the derivative of sine is cos, so it can be written as cos 3x square plus x into 6x plus 1. You can see that cos is the derivative of the outside function. Inside function 3x square plus x is as it is, and 6x plus 1 is the derivative of the inside function. Alternate way, find the derivative of y is equal to f of x is equal to sine 3x square plus x. Let u is equal to 3x square plus x. In this case, we are assuming that the inside function is equal to u. Then y would become sine u. Derivative of y would be calculated with respect to u, which is equal to cos u. As we know that u is equal to 3x square plus x, so derivative of u with respect to x is equal to 6x plus 1. By using expression double steric, we can write that dy by dx is equal to dy by du into du by dx. And after putting the results of dy by du and du by dx, we will get the required answer. Thank you.